Awesome. So we are live. Welcome to Local Stack community event. I'm super excited for the event today because we have amazing talks. So let me first introduce myself. I am Nancy. I am a DevRel engineer at Local Stack. I would love to make this event as interactive as possible. So please let us know that where are you plugging in from in the YouTube comment section. So for all those people who are joining for the first time, who are new to Local Stack, I would just love to tell you a little bit about Local Stack. So with Local Stack, it lets you develop and test your cloud applications locally to reduce development time and increase product velocity. It reduces unnecessary AWS spend and remove the complexity and risk of maintaining AWS dev accounts and test accounts, which we are aware of. So that is what local stack is all about. And today we're going to discuss about how we are streamlining the networking experience with local stack. We are also going to discuss about data streaming with local stack. So let's get started. So for today's agenda, we have intro and welcome. We are already doing that. And the first talk is going to be improving networking in local stack. And the second talk is going to be about AWS data streaming with local stack in action. And then we are going to have Q&A. So let's meet the speakers. Awesome. Max, Simon, how are you doing?
Hi guys.
Hi, how you doing?
All
I'm
good.
perfect,
So
fine.
yeah, thank you so much for finding out time. I mean, it's really tough to go through the presentations. We're going to have a lot of demos. So we would love to know about you. So maybe Simon, can you introduce yourself?
Sure. Hi, I'm Simon. I've been working at LocalStack for about a year and a bit or so. I'm primarily concerned with working on the core emulator, so the AWS part of LocalStack and all the services and some of the kind of core internals, and particularly up until now focusing on networking. So hence why this talk is kind of an initiative that I've been leading over the last, I'd say, nine-ish months or so. And hopefully we've made a big improvement in the way that users can interact with LocalStack over the network.
Yeah, that's amazing, Simon. I'm pretty sure a lot of people are waiting for this for demos and even to understand that how can they do better. So really looking forward to your talk. Max, what about you? Can you just introduce yourself?
Hi Nancy. Yeah. I'm Max. I'm also like Simon, similar like him, working in the core of localstack, and I'm focusing on like streaming services, data-related services. This is also why my talk will be related to this field. Yeah. And I'm definitely looking forward to giving more of a like hands-on, a bit like when you getting started with localstack. So yeah, this is where I think I will show you how to improve
Yeah.
your onboarding experience.
Yeah. I mean, definitely. I mean, your talk is going to have a lot of business use cases. So it's going to be really helpful today. Thank you so much, Max. Thank you so much, Simon. Yeah. So with this, we have met our speakers. Now let's see a few updates. Oh, sorry. Before that, I would just like to tell you that if you have any questions or if you have anything to say in between of our video, our event, just feel free to log in to slido.com and use the code. I'm going to paste this in the YouTube comments as well. So yeah, I'm just going to ask these questions after the talk, and then we can discuss this. So some developments, we had recently launched the Local Stack Academy Module 2. We have done a lot of hard work here. So it teaches you how to build and deploy apps using local stack, including creating infrastructure with Terraform and CloudFormation and CI workflows. So and it also tells you how to auto generate with IAM policies with policy stream feature, and you will also get to know about cloud pods. So if you're someone who is new to local stack, you can refer to our local stack academy and the new module. And we also have new blog post. So we have blog post around cloud pods, which is really amazing. If you want to work with your colleague, share the instance, local stack instance, you can read more about cloud pods. And we also have a community blog on generating IAM policies locally using LocalStack. There are other resources as well. We have videos. We also did community event last time, so feel free to check that. And last, we are going to have in-person meetup in India. This is Cloud Dev Exchange Bangalore. So with Cloud Dev Exchange, the whole idea is basically exchanging the ideas or maybe the work which you're doing around improving the experience of cloud toolings or maybe the infrastructure. So if you are working on the cool things and if you want to learn, so please feel free to join it on March 16. So with that, let's get started. Simon, would love to know about different networking scenarios. So yes.
Cool. Thank you very much. Hi, everyone. This may not sound like the most glamorous talk to start with, but it's an area where LocalStack has had some issues in the past. We get reports from users about connecting their applications to LocalStack. And as I mentioned, I've been working or leading this initiative for the last 9 months or so. So hopefully we'll see a big improvement together. So if I start at the beginning, networking, conceptually, it can be quite hard. Networking is, the user experience I find is not great when things go wrong. So you quite often get things like timeouts or cryptic errors from deep dependency libraries like OpenSSL, for example. Typically, the tooling that there is to work with networking can be quite platform specific. So there are different tools for macOS to Linux to Windows. Typically, the tools are older as well and maybe not as easy to use as some of the more modern tooling that there is for other aspects of computing in general. A lot of times, the settings that you may want to play with to access things like DNS or VPNs are locked down by system administrators. So it's not as flexible and easy to change as you might like. There's lots of acronyms. I've got some in my notes. There's like HTTP, DNS, TCP, UDP, IP, VPN, VLAN. It's a lot to keep track of. It's a lot that I don't know what they all mean, certainly. And when you add Docker to the mix, that brings some additional complexity. Again, this networking Docker works by isolating processes in namespaces. That's a bit confusing. There's lots of virtualized Ethernet going on and everything. So all in all, networking is a bit difficult. And I certainly have learned a lot coming along this journey as part of LocalStack. So let's have a look specifically at what LocalStack does to interact with the network. So I mentioned Docker before. LocalStack runs in a Docker container. So this means that it's got its own networking system within the container that's sort of shared with the host, but sort of not. I might go into further details later on. It uses an operation called publishing, port publishing. So this is saying that I'm going to say that port 4566 on my host computer connects directly to the Docker container. And this is how we get traffic into and out of that isolation system that Docker provides. As part of our LocalStack internals, we use Docker containers ourselves to run background processes or your application code, for example. So if you were to run, say, a Lambda function, that runs in a Docker container. And all of the inter-Docker communication has to be sorted out. And this leads to some very complex networking requirements. I mentioned even just regular networking on a single computer is hard enough. When you add Docker to the mix, it gets a lot more complicated. So I'm going to now outline a few common problems that we have either experienced ourselves or observed from my users. They're not specific to LocalStack, but we rely on these features to work as part of a functioning system. So there's this idea of port publishing. So what happens is when you publish a port from your container, there is a process called the Docker proxy that listens on your host system. This acts, as it says, like a proxy, and it sends requests from the port that you've published to the container, and it handles the reverse direction as well from the container back out again. But each interface, technically, so your local host interface, can only have one port assigned to one program. So, for example, it's more, should you wish to, you can't run 2 copies of LocalStack with its default configuration because there's already ports bound by this Docker proxy. more kind of relevantly is that you might have another server listening on a port, and you can't have two servers listen on the same port, for example. As a part of the way AWS works, AWS is centered around sending network requests. AWS itself uses subdomains very heavily. So, for example, I've got here the subdomain way of addressing an S3 bucket. So it's the name of the bucket .s3.region.amazonaws.com. LocalStack does something very similar. We use subdomains in the URLs of requests that are made to LocalStack to send those requests to different services to make sure that we are handling the request correctly. And another aspect that is a common problem is TLS, so HTTPS communication. It requires a certificate of a proof of ownership almost that the server is correct, or the server owns that domain name. And that's not always easy for a local development like this, like LocalStack is really is really suited for. So as part of this talk, we're going to walk through a problem. It's an example application that I've set up. It's a very simple application, but it's kind of representative of some of the situations that users have come to us with questions and issues, and we have tried to resolve as part of this initiative. So I'm going to switch to my terminal now. Hopefully this is okay to follow, but what we have on the left here is two files. So the bottom file here has a little diagram of what we're going to build, or what I've built as part of this demonstration. It's within a Docker network, and it contains two containers. I've got the LocalStack Docker container, and I've got my application Docker container. The application is going to be interacting with LocalStack as if it were AWS, so I can develop my application as I go along. Make this a little bigger. And if we kind of drill down into the details, here we see this is Docker Compose. Apologies if you're not familiar with Docker Compose, but it's a declarative way of stating which containers I want to run and their configurations. So at the top here, we have a LocalStack container. This is pretty much copied and pasted, I think, exactly from our Getting Started Quick Start guide. If you were to look up if you go to the LocalStack repository on GitHub, you'd find the Docker Compose file that looks like this. Nothing unusual. At the bottom here is my application container. So this is my kind of business logic. This is the thing that I want to interact with AWS. So I've set a few variables here for the environment. They are to configure AWS clients. It's just to save me specifying too many things. But the key part for this application is that it's going to be listening on port 5000. So specifically, Docker is going to publish port 5000 onto my host system. And this is so that I can interact with the application from outside Docker. The application itself is this file at the top here. This is in Python, and it's using Flask, which is, apologies if you don't know Python or you don't know Flask, but it's a web server library that you can use to create simple web servers. It exposes two endpoints, health and queues. Health just exists for me to check that it's working. And queues is where we're going to be focusing on. So in the queues endpoint, what we do is we use this client object. This is part of the Python's AWS SDK, how we interact with AWS day-to-day in Python. And it's created up here. So we don't provide any arguments. We're expected to take things like credentials and the AWS region that we're operating in from the environment. It's a fairly standard way of interacting with a language SDK like this. All of the configuration normally is read from the environment that the code is running in. So what we do here is in our queues endpoint, we list all of the SQS queues that we have in our account in this particular region, and we're just mapping the result to make sure that there's something to show. Not very interesting. And then we're returning that as a JSON object. So throughout the course of this presentation, you'll be seeing me run this code in different versions of it. And I'll be doing that in the top right here. So I'll be running it with this command, docker compose up. So this launches these two Docker containers. And I'm also adding the -- build flag just to make sure that if the container needs rebuilding, it gets rebuilt. And you'll see output in both yellow, which is the local stack logs, and you'll see output in blue, which is the application logs. The specifics of this pane don't really matter, but it's there for primarily me to make sure that everything's working. What I can do now is interact with my application. So I mentioned it's got two endpoints, health. I can make a request against the health endpoint, and that tells me that the application is up and running and it's working, at least as far as the Docker container is concerned in the networking. Let's see what queues there are in my account. I mentioned we're doing this list queues operation as part of this handler, so now let's invoke this. And we get a nasty looking error. This is unfortunate. This is because I mentioned that the AWS client takes all of its credentials from the environment, which is what we've defined down here. So access key ID and secret access key. These are not valid values. So unsurprisingly, AWS is saying, no, you can't list the queues in your account. So faced with this issue, what I want to kind of emphasize as part of this work is the first thing that we did as part of this initiative, which was to build out some documentation and troubleshooting guides. So what we created in our documentation, there's a link here and we can circulate the link afterwards, is a series of scenarios that a user might be faced with when they're dealing with localstack, trying to connect to localstack with their application, so on and so forth. And we created these little schematics and pictures. So let's go through the process of trying to troubleshoot this networking problem. So we're not using a resource created by localstack. We're trying to interact with localstack directly. And we're using a language SDK. So we'll go to this panel on the left. And we're accessing it from our container. I'll talk about some of these other situations later on, but at the moment we're focusing on from our container. We would click on this. I happen to know what the guide tells us. So let's go back to what I've been calling internally the seamless connectivity. This is now where we are with localstack 3. This is current implementation of how we improve the situation for our users. So I'll switch back to the terminal. To save me typing, I've made all the changes in a Git repository, and I'm just going to change branches, and that's how I'm going to make the changes because I don't want to type in a live demo. So I was on branch demo 1. Now we're going to go to demo 2. So I can tell you the solution that the guide tells you is to try and use the domain name localhost.localstack.cloud. And we'll see that if I check out this branch with the latest changes. What we can do is we can see the change I've had to make to my application is now the SDK client takes an endpoint URL parameter. This is saying every request you need to make to what you think is AWS, send it here instead. And I've specified localhost.localstack.cloud. Now as a bit of a kind of demo, I'm going to show you one of those archaic tools that I mentioned at the beginning of this presentation, which is I find particularly not friendly to use. I want to know more about this localhost.localstack.cloud domain name. So I'm going to use a tool called dig. I can't remember why it's called dig, but it is. And we can investigate more about the domain name localhost.localstack.cloud. When we do this, we get a lot of output. I can tell you a lot of it doesn't matter. It's kind of unintuitive, but the thing we're interested in is this section here called the answer section. It's kind of confusing, but the answer section tells us that localhost.localstack.cloud maps to the IP address 127.0.0.1. So you might be asking, well, how are we able to use this domain name 127.0.0.1 in our application container? If I go back to the top here, the application is not running localstack on its local address. It's in a separate container. It's got a separate IP address. So how does this work? The way we've implemented this is we have introduced a DNS server. So DNS being the domain name system. It maps, as we saw here, domain names to IP addresses. The DNS server that's running in localstack will, for a select number of domain names, return the localstack container's IP address. So if I were to make a query from the application container, which I can do if I start the application, I can run docker exec, docker compose exec app. So this is this application, and I can spawn a bash shell inside this application now. It's running. I can do again big localhost.localstack.cloud. And previously this returned in the answer section 127.0.0.1, but now it's a different IP address. Where is this IP address come from? So I mentioned previously that the DNS server responds with its own IP address effectively, the IP address of the local stack container. So the application says, before it makes any request to AWS, it says, can you give me the IP address for localhost localstack.cloud, please? And the DNS server will say, okay, my IP address is this 10.0.2.20. I'll return that. And then the application with the configured AWS SDK knows to make requests to the local stack container. So with this small change in our application, we're able to connect to local stack fairly straightforwardly. I can show you this if I curl the queues endpoint again, and we see we have some queues. What's really useful about this is on the host, I showed you localhost.localstack.cloud resolves to 127.0.0.1, and port 4566 is published to the host. So we can add a queue from the host. So we're not inside the Docker container here, we're on my host system. I can run SQS create queue, and I'm just calling it foo. Then I can interact with my application and it lists my queue. So we've got connectivity to local stack from outside the Docker ecosystem and inside the Docker ecosystem. This doesn't come quite for free. There are previous versions of the networking guide before we implemented this DNS system that mentioned things like if you're inside a Docker container, inside a Docker Compose stack like this is, you can address containers by their name. So rather than localhost localstack cloud, I could have used localstack, but there are downsides and problems to that made us look a bit further. So we wrote the documentation guide. We realized it wasn't quite complete, didn't give us as seamless a connectivity as we wanted. So we continued to work and implement this DNS-based system. We are going to be publishing a blog post very soon with more details about the initiative and the kind of the advice for where we're going, and also how this system works. So look forward to a blog post on our blog coming up very soon. So this is good. This gets us connectivity between our two Docker containers. So it also, what's really nice is it also supports
Yeah, I was muted. Seems like there's some network error on Simon's side. I mean, we were just having such an amazing presentation on networking, cool demo. But yeah, I mean, I guess let's wait for Simon. Let's wait for a couple of seconds, couple of minutes. Meanwhile, I would just like to tell you that we have this documentation, and Simon already mentioned about it. We have this amazing networking troubleshooting guide, which we have created. Let me just share the link with you as well. Cool. So I guess you can see it over here. So you can refer to the docs, the references, networking troubleshooting to see if you're stuck with something while trying out LocalStack. If you have some networking issue, you can always try this. And if you have any issues as well, you can also reach out to us on Slack. so that we are able to answer you or maybe help you. Cool. Also, meanwhile, I would like to tell that if you have any question till now for Simon or for maybe me or for anything, you can ask a question on slido.com using the code over here. Yes. We should be right back. Let's wait for Simon again. Yeah, meanwhile, maybe let us know that where are you plugging in from? Okay, so I guess Simon is back. Hey, Simon.
Hi, sorry about that. I don't know what's happening.
Okay,
I've
that's a
got a different computer.
yeah. Yeah, we should maybe start again. I mean, that was a lovely demo. We were really into it. So yeah, let's get started again. Yeah, maybe you can present your screen.
Look. Apologies about this, everyone. Okay, so where were we? Apologies for that. So I was talking about DNS. So one of the challenges that I mentioned earlier is that subdomains are very important to AWS and they're very important to localstack as well. So one of the nice features of our DNS resolver is that we resolve every subdomain of localhost.localstack.cloud to the localstack container as well. And I can show that off by going back into the container. I've restarted it. Unfortunately, I'm going to have to rebuild the container now. So I'm on a different computer now. I do apologize. The fun of live demos. So when the container runs, I'll be able to make a DNS request against the localstack container for subdomains of localhost.localstack.cloud. So let's see that working. Okay, so I can do dig bucket.s3.amazon localhost.localstack.cloud. It still responds with the IP address of the container, 10.0.2.20. There is some configuration that has to be done on the user side now. So on the environment of the application container, there are a few changes that need to be made. So the first is we need to tell our application container to use localstack as its DNS server. And the way we do this is with this DNS entry in the compose file. So we can set this to be a list, in this case, one of DNS servers that we're going to use to resolve localhost.localstack.cloud. Here I've put the IP address of this is the localstack container because we need to use localstack as the DNS server. And I'll tell you how we get this value later. In order to do this, we need to configure the user-defined network for Docker. So when you put containers in a Docker compose file, they become part of the same user-defined network. And user-defined networks have got a lot more power and configuration than the standard network does. When you start a Docker container without specifying any network, it gets put in the default bridge network. But that's static and not very configurable. This is a user-defined network, and we've called it LS for localstack. and it provides extra configuration. The one we need is to give the local stack container a fixed IP address. So in our local stack config, we're saying that the local stack container belongs to the LS network and it has this static IP address. And then the final piece of configuration we need is to say that the Docker doesn't allow you to assign a static IP address like this to a single container. You have to define what's called a subnet, or a range of IP addresses that Docker is able to choose from when running containers. So in the network configuration of this LS network, we see we're defining the subnet to be 10.0.2.0/24. I won't go into details, but this means that anything that starts with 10.0.2 is in the same subnet. Docker will pick an IP address out of this IP address range to assign to the app container. So that's how we get the two Docker containers in the same Docker network and the same subnet that's implicit as part of the Docker network, and one container is able to talk to the other. Let's see what else we can do. I mentioned the subdomains work, but what about, there was another item on the list. So we've got subdomains, we've got no ports are being published to the host. This is all done within the Docker network, so we don't have any port conflicts. Something else that was mentioned in the problems was this idea of HTTPS and valid certificates. So it's very hard to generate a certificate for localhost. I think it's somewhat frowned upon, apart from local development and that sort of thing. But if we check out the next stage of my demo, what's changed? Now you can see that we're using HTTPS to connect to localstack. So again, we've got the domain name resolving from the DNS server as part of localstack, but now we're able to use HTTPS. We have a trusted certificate for localhost.localstack.cloud and subdomains that we can use to present a valid trusted certificate to any clients like this Boto client. You'll see the port has gone as well, and that's implicit. HTTPS by convention is done over port 443. If we have a quick look in our compose file though, this I want to emphasize how this is working, but we're not exposing port 456, we're not exposing port 443, we're not publishing the port. This again, to emphasize, is all the traffic is going over the Docker network. It doesn't care about ports published to the host, that's separate. We're able to make that request against port 443, even though we're not publishing that port. The configuration change we've had to make was another aspect of this networking initiative, was to streamline and improve the configuration for localstack. So before the initiative, for those of you who've been using localstack for a little while, you might have remembered variables such as edge port HTTP, edge bind host, localstack host name, and host name external. Those variables, they had a mixed role within localstack. Some were used to configure the container, some were used for what I've been calling cosmetic purposes. We'll go into more details as part of the blog when that gets published, but for now, we're able to use this environment configuration variable gateway listen to tell localstack to listen on both 4566 for the host and 443 for the container, for our application container. That's not how you type. So I can run this new stack with HTTPS in our Boto client, making requests to localstack, and we get a valid response. So everything's working again. Now everything's actually encrypted, all the networking traffic. This is local and perhaps not the most important thing, but it emphasizes that this is showing the maturity of this networking implementation as well. The final thing I want to demo very quickly, because I think I'm running out of time, is a change that was actually provided to us by AWS rather than ourselves, but it's something that we are making use of in localstack. So if I take a look at demo 4, the application itself has returned to its original state. I can show you this if I diff the first state we started in with the state that we are now, scoping it just to this application file. The code Okay, it's not quite the same. I've made some renaming, but the code is nominally the same. The client setup is exactly the same. We're not configuring the client. It's all done through the environment. Recently, AWS introduced an environment variable called AWS endpoint URL, which is used to configure some client SDKs. Depending on the language and depending on the version, you may find your applications will work like this. You can configure this environment variable to point to localhost, to point to local stack, and then your application code. This is the same as what you'd write on AWS. It's a really cool time to be working with localstack at the moment, because you get this. The changes you have to make to your code to make it run on AWS versus localstack is getting smaller and smaller, and I think that's really exciting. I should mention that if you're using some of our runtime environments, so particularly Lambda and ECS, we inject this variable for you. So you don't have to, if you're using an up-to-date SDK with the right language, you don't have to change your code again if you're talking to AWS resources. We'll inject this AWS endpoint URL for you so that the clients know where to make their requests to. So now if I switch back to the presentation. So if we go back to our list of issues that we had at the start of this talk, we had only one process can listen to a port on an interface at once. This is the port publishing problem and port conflicts. Well, this is now gone. If you're happy to work with container-to-container networking, you don't need to care about port conflicts. Trusted TLS certificate cannot be created for localhost without configuring the host system. This is also gone because localhost.localstack.cloud is used throughout, or if you use localhost.localstack.cloud throughout, TLS certificates can be used and HTTPS traffic can be used. And finally, AWS about subdomains. I mentioned before that subdomains of localhost.localstack.cloud also resolve to the localstack container. So in summary, this initiative has streamlined the way that users' code connects to localstack. Hopefully you've seen how much more straightforward the application code was. There are reduced differences in application code. So again, that parity between your code versus localstack versus AWS is getting closer and closer. We have the network troubleshooting guide, as I mentioned, if you have any problems. The networking component is open source, the DNS server. We welcome contributors for that. And we have our community Slack channels and other ways to reach out to us if you have any questions. And as I've mentioned, there'll be a blog post with more details coming out very soon. Just another mention of the network troubleshooting guide. And finally, next steps for me. So at the moment, I'm currently looking into networking, but also increasing our support for other container runtimes. So I've mentioned Docker a lot in this talk, but there are other container runtimes such as Podman and Kubernetes. We're looking quite heavily into increasing our support for those runtimes. Part of the networking initiative, we're looking at TLS certificates in more depth. So we have our certificate at the moment, but we're looking at dynamically generating and dynamically trusting as part of localstack's operation. And in the more distant future, we're looking into more accurate EC2 networking primitives and emulating their behavior. So subnets, security groups, VPCs, that's so on and so forth. And that's it. So thank you very much for your time. I apologize again for dropping out on you. I hope you're all still as entertained as I hope you are. And thank you very much.
Awesome. So it's Q&A time. Again, I just want to mention to everyone, thank you so much for your patience when we had networking issue. So because we are over time, so I'll keep the questions less. And if you have more questions, maybe, you can just ask that in Slack. And Simon is there. We are there. Ask that. So I'm just going to put the question, what can we do if we are using transparent endpoint injection to redirect AWS request? How to access localstack?
Fantastic question. Thank you. So transparent endpoint injection is a feature for our paid for image or paid for version of localstack. You've seen how some clients interact, or some clients work with transparent endpoint injection sort of as in out of the box as in the demo. But we provide more. If your SDK or your language, for example, doesn't support the AWS endpoint URL environment variable, then we implement transparent endpoint injection on our side as well. So our DNS server will intercept requests to the IP to find the IP address of AWS URLs as well as localhost.localstack.cloud, and it will redirect those.
Awesome. And I think we also have this in our troubleshooting guide. So maybe please feel free to refer that again. We have amazing diagrams explaining this thing. So it's going to be, I mean, illustrations are always a better way to understand, for me at least. So yeah. Okay, so this is going to be the last question. For new users, what best practices can you suggest, offer to ensure a smooth experience with setting up and configuring networking with LocalStack?
Sure. So I would say it's split into two. If you're using one of our managed environments like Lambda or ECS, then that should be done for you. And we have good documentation on those services specifically. If you're in a situation like I was demonstrating, then I would suggest trying to configure your application to use the localstack's DNS server in a Docker environment and using localhost.localstack.cloud throughout. That will give you the most straightforward experience as you get started.
Awesome. Thank you so much, Simon. That was really amazing. Thank you for the demos.
Thank you.
Awesome. So maybe we can move to the next demo. We can have Max. We can have Max. We are going to learn more about more and more demos. We're going to learn more about AWS data streaming with LocalStack in action with Max. So over to you, Max. Let's get started.
All right, thank you, Nancy. Thank you for handing over to me. So yeah, following Simon's talk, I will also show you how you can utilize LocalStack for deploying a data streaming application. So maybe let's first look into a broader overview what actually data streaming is. So why is it not switching? No, it switched too far. Okay. So in general, when we have been doing data processing in the past, we mostly use batch processing. But now more and more data streaming and processing data in streaming services is coming into like applicational development. And this is mainly, I think, three main reasons. So one big reason is that you can process data near real time, especially like utilizing AWS services. You can, very, very small latencies with putting data through your system. Also, these services tend to be way more scalable and also reduce like throughput and latency to the scalability of the services. And due to their design, they tend to be way more fault tolerant because even if you encounter some issues, you don't necessarily lose batches or have to restart from a batch processing part, but you only use like very, very small increments, and they are like fault isolated to these small increments. And AWS has quite a number of data streaming services available. But in general, if you start out fresh, you would switch to Kinesis, because Kinesis, this is basically their primary offering of data streaming service in the AWS ecosystem. And this is due to several reasons. Mostly the reason it is fully managed, so you have to, if you don't want to configure the least amount of things under the hood, and it runs more or less right out of the box as you intend it to run. It's very scalable, so you can configure it to auto scale up and down depending on your throughput volume. And this, of course, helps you to reduce cost and in the end save you money, which is always a intended thing, especially when deploying large workloads on AWS or on any cloud provider. And it also is it's deeply integrated with other services. So it is out of the box integrated with a lot of other services downrange as consumers, but also a lot of services can directly write into Kinesis data streams without having you to use some kind of Kinesis client library to configure it. But of course, you can also send data from your endpoints from mobile devices into it. So I said we are going to look at a more or less real life business case to then use this to see how can we use and leverage data streaming services, Kinesis, something around Kinesis. And a business use case which I encountered in real life with a large company already is a bit abstracted, but basically you have a novel device where you can generate or gather some health data. This could be heart rates or some more abstract measurements you do with your users. This hardware device is connected to your mobile device, and the mobile device then sends this data to your cloud pipeline. And you want to have, maybe you're a smaller company or you're a larger company and you already know that you're going to have thousands to millions of customers, but you want to basically be able to scale. So it makes sense to keep that in mind, to be able to scale to your next big unicorn, to have millions of devices. Every second person will use your novel hardware tracker. And you also want to be able to query this data. On the one hand, maybe to train your models, to do predictions, maybe in real time with this data which is coming in, but also for your data scientists to use the vast amount of data you're going to build with your new unicorn startup to generate better models to make better predictions. So considering this business case, we have to get together as engineers, and we have to think, okay, how can we basically provide an infrastructure, a target architecture that fulfills these requirements? And in this case, we looked at the offerings from AWS, and we said, okay, Kinesis. Kinesis is the way to go for us, but we also want to be able to give our data scientists a way to query the data. So we need to store it somewhere. And most of our data scientists, they happen to work with Jupyter and SQL. So we found Redshift as the suitable data storage for these devices to be able to also work with machine learning models maybe in the future. And to distribute data from our streaming service, where our clients are writing these into the stream, to our data storage, we are going to use AWS and Amazon Data Firehouse. We recently renamed it, I think last week, because it was named Kinesis Data Firehouse, and they probably thought, okay, too complex. They renamed it, so now it's a bit more simpler. And how this will work is that Kinesis can directly connect to Amazon Data Firehouse, and this then lets us write to additional services. So Data Firehouse in this case, and in a lot of other cases, is kind of the glue in between services to distribute data. This is also probably why they call it like the fire hose, to spray data from somewhere to somewhere else. And we also want to store the data in a S3 bucket for later retention, so that just to make sure that we have always the raw data. And then how Data Firehose in this case distributes it to Redshift is that we store it in an intermediate bucket, and then Redshift read operation is triggered from there to read it from this bucket. In this particular instance, also because we are going to right away implement the tech stack that will work against AWS, not only localstack, we have to consider that AWS, from good reasons, doesn't want us to directly connect to Redshift. So it is in a private subnet in our VPC. And so there we also have to configure a EC2 instance, which we can then SSH down through it, which is at a later stage important. Okay, so enough talk. Now let's switch to actually showing you how you would build that with localstack. So first thing, you would probably set up your environment. There we have excellent guides on how you can do that. You have to use Docker, some similar runtime environment that enables Docker commands. So Docker desktop usually is the way to go. And you have to set up your dev environment. In this case, because we are also internally working with Python, I'm going to do that in Python. And I'm going to implement the target architecture using AWS's Cloud Developer Kit, which is a way to define infrastructure as code, programmatically define this infrastructure. So let's switch over to the demo I prepared. So let's get rid of this because this is already working. So if you want to work with CDK, you have to follow some principles which are quite well documented. So we are going to create this application, and with this application we can bootstrap and then deploy our stack, which we are going to define first the stack in a separate class. So let's also get rid of that because we want to basically start from scratch. So in this case, what would be the first thing which we want to deploy? So the first thing which would be probably the Kinesis stream. So in this case, we can look at the documentation and think, okay, we have a nice sample construct. So with CDK, you have several levels of constructs. There are L1 constructs, which are direct mappings of to CloudFormation commands. And you also have L2 constructs, which are more abstract. So AWS does the work for you. They think of how do you want to deploy, what is actually necessary to deploy a complex resource, and then they map that to an L2 construct. Sadly, for our use case, there are no L2 constructs available, neither for Firehose nor for Redshift. So we have to implement most of it ourselves. But let's get started with that. Let's basically first see how we can set up a Kinesis stream. So here we define it, we give it a constructor, and we define how many shards we have. For that, one shard is enough, and how we want to provision it. In this case, we want to have it provisioned, not the on-demand stack. Then we're going to import it here. And we are going to define it. So we're going to build it here. Let's say we are giving it that. And then now what we can do in the past, or what you usually do, you would now deploy the stack against AWS. But we can leverage localstack to speed up that process. So let's first start our localstack container. So we can see here that on our Docker, our localstack container started. And let's also see that no services are currently running. So this queries our health endpoint, and we can select or filter it against running services, because we give you that information. We see, okay, our localstack container is running and no service is deployed. So let's now bootstrap that and deploy it. So first, because we're always starting fresh, we have to install the necessary requirements with bootstrapping our environment. This can be done here. This command, so we also supply a Node.js application which mimics the CDK application, and we call it CDK local, and with that you can interact with. That is not what I intended for that demo. So we are seeing that we are bootstrapping our stack. This deploys some required resources for CDK, for the CloudFormation deployment. Perfect. The next step would be CDK local to synthesize. So basically generate our CloudFormation template, which is then used to deploy the declared resources. In this case, only our Kinesis stream. And then now we can deploy it. And we have to declare our stack here. Let's wait a few seconds. Yeah, there we're seeing the operations that happen in the background on our container. Okay, so now if we again query and Yes, now we should, this is not well formatted. Now we should see that we have several instances running. We have the Kinesis stream running, we have an S3 bucket running, because the S3 bucket is required by CloudFormation. We have these services running. Okay, so generally this would be basically the first step, but this is not our target architecture. So we still have to deploy some other resources. And this would be, for example, we have to deploy an S3 bucket. So for that, we can again look at the documentation. What would be the definition of how we declare an S3 bucket in CDK in Python? And therefore, we first have to import the module, and then we can declare it here. Other things we also have to consider, because we intend to be able to also run it against AWS, we have to define the correct policies. So in this case, this will probably also, if you use IAM policy streaming, can help you leverage localstack to quicker iterate to find the correct policies. I have now done the work for you. So I already did that iterative process to see what the right policies would be. And if we have that, then we can actually look at the next component, which would be firehose. So in this case, we have to look at how can we define firehose that it knows that it should listen to a Kinesis stream and that it knows it should write to the correct S3 bucket. So therefore, we have to declare several other things. So let me copy that over, because this is quite a lot of code, and then we can go through it. So first, we have to define the firehose Kinesis source configuration. So this tells firehose, okay, listen to this Kinesis source stream source. There's also a thing that if you want to get logging on errors, we have to create a log group and define this log group. We have to specify the role that firehose uses to access the S3 bucket. And we have to define a configuration for firehose to know to write to this S3 bucket. And then here we can actually create the firehose stream. So let's test that out. Let's import first all the required dependencies. That should be done. And then we can switch back to this. We can run again, synthesize to update our CDK definition to add the new resources. And then we can deploy it. And now what it will do, it will generate a change set, and we'll only look for the change resources and deploy that to our local stack running container in the background. So it will ask us, and we say, yes, let's do it. And if we copy or we made all the correct configurations, which in general is an iterative process. So what you're seeing here is the result of me iterating through it, reading through the documentation, figuring out where I made some mistakes. And localstack vastly sped up this process, because I don't always have to wait until the resource is deployed in the cloud, which generally takes longer, but I can deploy it locally and quicker iterate on it. Now, let's hope that I didn't jinx it with saying that it's quicker. But we are seeing that things happening in the background. Yes, now it deployed. And now we can again look on what services are running. And there is our firehose now running also, which is nice. Okay, this would be the first step. The second step, I guess, would be to bring in Redshift. Now, there's a bit of an issue, because if you to configure the destination or from firehose that it is Redshift, we first have to have a running Redshift cluster. So we have to split up our stack. We first have to deploy the Redshift stack, wait until this is running, and then we can query some information from that to deploy our firehose stack. So I also prepared that already for us, so we can now go a bit quicker through it. So this would be, in our case, the Redshift cluster. And then we also have to add a second thing, a second configuration to our firehose, which is the Redshift destination configuration. And the documentation is sadly a bit sparse for that, but yeah, this will also be probably made available to you via our templates and examples. So now, just to be sure that we don't mess up anything with our existing deployment, I'm going to stop our container and restart it. So basically start out from scratch. So we know that we are not interfering with anything. And yes, I also made a small make script, which will just run through the bootstrapping, the synthesizing, and the deployment of both the stacks. So we can run that, not this one, and deploy it locally. And let's hope that we made enough offerings to the demo gods that this will also run smoothly now. I think last time I ran it, it took about 2 minutes. But what I want to show you in between, in the meanwhile, is that comparing how fast it takes to deploy that for localstack compared to AWS. And I made a small video basically executing both of these commands side by side to show how fast this takes. I mean, this varies a bit, but overall, these were the numbers I got. And I guess we will not sit through the whole video because 23 minutes is quite a long time, even though I sped it up. But we can see that we are here a bit ahead on AWS because the bootstrapping step is already done for us because we are not going to bootstrap the AWS environment all the time. And yeah, after, what was it? I didn't even pay attention. 2 minutes, localstack is already done, and AWS is not even deployed the first part, so our Redshift stack. Of course, this is also an issue because Redshift tends to take quite long. So for simpler stacks, this will be not such a big discrepancy. But again, we can see if you are still in the iterative approach, this vastly increases your development time because you can quicker deploy and redeploy. So let's look at that. Okay, we still have not deployed it successfully, but we already deployed the second part, the firehose stack. So let's give it a few more seconds. Meanwhile, I can yes, so now it's deployed. So what do we want to do next? So next we want to simulate our pipelines. We want to put some data in to the Kinesis stream and see where it ends up and see if it actually ends up in our Redshift database. So for that, I just wrote a small mock producer and we can run that with, again, a make file. And this is just, yeah, it just puts data into our Kinesis stream and then simulating again, and let's say a data scientist who would use a Jupyter notebook to investigate that data. We can now, let's first look at the raw data in S3 bucket. So what I'm doing here is I'm using a Bodo client to locally look at the localstack S3 bucket, which we created with our stack. And let's see, okay, so there's already data in there. It's a bit messy, but we see that data is coming into our bucket. And this should increase actually, yes, because I'm basically every 10 seconds, I'm putting new data into the Kinesis stream. So let's look at the Redshift database. So I'm just connecting to the table we set up and defined locally. And we are also getting data in here, which is again also increasing. Just as a simple demonstration, this would be not probably your next unicorn startup if you only generate this kind of data, but to show feasibility, this is how data would end up. And you can then, for example, visualize it, which makes no sense because this is completely random generated data. But yeah, you get the point. So this is basically how you would leverage Kinesis, Firehose, and Redshift on localstack. And again, taking this time savings into consideration, it vastly speeds up your process. Also, what is it? Let's move to the next slide. A real benefit if using localstack, especially in the beginning of the dev process, but also later on, if you want to test something, you can completely set up your dev environment if you have the infrastructure as code and test new code against it. This is especially interesting if you have large data sets and you want to introduce, for example, you want to change the data layouts or want to change something with the data and you don't want to risk anything with your processing and data which is in production. You can, of course, have several accounts, but then again, you run into this problem. What if you have a lot of developers? You will probably not have one account for each, so they will also step on each other's toes. Yes, that's what you can get rid of with localstack. And in addition, this is what in this case is maybe a feature, especially looking at Redshift. You don't have to jump to these hoops with connecting to an EC2 instance because you cannot access your Redshift database, because when you run it locally, you can directly access it. So yes, that would be actually it from my side from this presentation. I hope you got a nice intro into how you can leverage that. This is a feature which we're currently working on, and the complete pipeline you saw will be available quite soon. So
yeah, that's really nice. Thank you so much, Max. Really loved the benchmarking which you did. That's amazing. I was like amazed seeing the numbers.
This will, of course, vary if you have a less complex stack. This, in particular instance, because we are deploying this Redshift cluster, it's quite long, but yeah, it's fast time saving.
Yeah, I'm just imagining if someone is working on the test environments. If someone is pushing the changes again and again, they'll have to wait for like those 20 minutes again and again. So this gets better with localstack. If we just have 2 minutes, we can keep doing the testing part. So yeah, that's really nice. Thank you so much for doing the benchmarking and for the demo. Max, we have some questions. We'll keep it less because we are already over the time.
Yeah, we're already over time.
Yeah.
I think also everything can move to like the Slack community chat. I'm very happy to like answer your questions directly.
Yes. So I guess
yes, definitely. It is because of this, what I just said, this missing L2 construct. It's hard, and yeah, it was very frustrating also to figure it out. But definitely, this is something which we can, on the one hand, definitely can. You can connect with me on the community chat. I'm same name, Max Weiser. Then we can have a chat there, and we are also going to refine this and share that as samples. Yes.
Yeah, and we can have this over localstack samples, which you can find over GitHub, and you can find other examples as well. So I'm just pasting this link over here, which is Developer Hub. So you can also go there, and you will be able to find other examples as well, which is using the similar technology like Redshift, Kinesis, and let us know. And if you have any sample which you would like to maybe contribute, which you would love to see in localstack samples, maybe you can just ping us over Slack. So moving to the next question, this is something like if you have any recommendations for troubleshooting the issues or debugging the data streaming pipelines when using localstack for testing.
This is difficult because I don't necessarily know what you actually mean with this, because it's a very broad topic. But on the one hand, what I found using that and deploying this, what I just showed you, is it helps that you can directly connect to the services and you can monitor each step in between. So what I did, for example, first I just looked at, does the data actually end up in the S3 bucket? And then if I'm sure that it ends up there how I expect it to be, because I can going to directly query S3 bucket, I'm going to look at where does it end in the Redshift cluster or the Redshift database. So what helped me was being able to stepwise see how the data travels to my system to localize where the issue occurs. Yeah, and this is definitely more easy with using localstack, because you can access all services directly.
Yeah. Awesome. Thank you so much, Max, for your time. And maybe we can also share the sample, which you have, the demo sample later. Maybe I can share in the YouTube comments. later when it's up there on the local stack samples.
Yeah, like I said, we're still ironing out a few bugs. We're still working that this runs smoothly, and this then also released to our containers so that you can can use this functionality.
Yeah. Thank you, Max. So yeah, with that, we are almost done. And I would just love to say that thank you so much for being patient. We had networking issue, but thank you so much for being patient. I would like to say thank you to all the community people. If you have something to show, maybe if you have something to contribute in any form, maybe it could be like blogs or maybe the code, or maybe if you want to advocate about local stack, please feel free to tell us over the Slack, because that's the best way to communicate or reach to us. So do tell us over the local stack community Slack. And yeah, thank you so much, Max and Simon, for your time, for the demos. It was really amazing. Thank you, Lazar, for being backstage and helping us. And thank you, everyone, for joining and being patient.